will also be video recording this so that you can refer it for the future purpose. So for this I took a simple data set. Let me show you the data set. Yeah, this is my data. This is how the data sets looks like. It has two variables called height and weight. Now we'll build a model on this. First I'm setting my work directory. This is the command. Then we are reading the CSV file into a data frame called HW, so which denotes just height and weight basically. So now in order to see the values in particular data frame, I'm just executing that, and now here we can see the values in that particular data frame. We can see that there are totally 28 rows and 2 columns. So before doing any model, we can just find the relation, how these two variables are related, how is the data looks like. So for that I'm just plotting the relationship between height and weight using the plot function. So once I gave this, we can see that this is how the data looks like. Okay. In the plot function we have various other parameters, like we can specify what is the x-axis, y-axis, and what should be the title for the plot, etc. So for that, to specify the x-axis label, we use a parameter called xlab, and I'm here giving it as height, and y-axis I'm giving it as weight, and here the main denotes the title for the whole plot. So once I execute this, it will give me, yeah, now we can see that the y-axis is labeled as weight and the x-axis is labeled as height, and the title for this whole plot is like model for weight. Now here we can see that there are the points are denoted by circles. We can change this by specifying different PCH values. So if I say PCH equals to 2, it will give me a different kind of dots. So yeah, like that. If I say PCH is 19, it gives me a different kind of dots. These are dark filled circles. We can also specify whether we want to draw a line between these values by giving an additional parameter called type equals to L. Yeah, the data is not sorted, so it is looking like this, but otherwise if the data is sorted, it will connect the dots sequentially. So let me remove this L. In order to know the various types of lines or options available for plot, we can just say help of plot. This will give us the various options available while drawing the plot. Here when you can see here that for the type, we can see if we specify it as P, it will give us points. If it is L, it will give us lines. If it is B, it will give both the lines and points, and similarly there are other options. Yeah, here we can also see that using the plot function we can also draw a histogram by just specifying type is equal to H. This is the plot. In this line I'm trying to find out the correlation between the various variables in my data frame. So when I execute correlation of HW, it gives me the correlation between the height and weight. Correlation expresses the linear relationship between the two variables. So the linear relationship between height and weight is, we can see that it is 0.7. So generally the correlation between two variables will be from -1 to 1. So -1 specifies a strong linear relationship which is a negative, and +1 specifies the strong linear relationship which is like positive. So correlation gives that thing. Here we can see that between height and weight there is like good correlation, that is 0.7 is a good correlation. Now I am trying to build a linear model between this height and weight. So I'm just giving model is equal to linear model and specifying the y variable here and then x variable. So y tilde x will give us the linear model between y and x. So control enter. Yeah, so the linear model has been built. We can see that here. Yeah, you can see the model is built. Now I just want to know what are the coefficients of the model that has been created. Here we can see that the y-intercept is this and the x-intercept is this. Sorry, slope is 5.488. The summary will give us all the details regarding that particular linear model which we built. So most of them are, we don't use it in our things, but yeah, this will give us a total summary including the coefficients, median, minimum value, max value, everything. So now we have the slope and y-intercept. We will draw that particular line using the function abline. So specify the keyword abline and give the model for which we want to draw the line. That, yeah, sorry, you can see that now that is the model which we built. So the values on this line will be the predicted values and these actual dots are the actual values. So now the difference between these two values, the predicted and the actual values, will be given by the function residuals. So when I execute residuals, we can see that there are some differences. Some of them are positive and some of them are negative, because we can see here that some of the dots are below this line and some of them are above this line. So with the model, say for height 64, the weight will be something around this, like 130, but the actual value is something around 120. So the difference between these two, actual and predicted, will be given by the function residuals. Yeah. So this is all regarding the plots, correlation and abline and residuals. Yeah.
Are the numbers 1 through 28? That is the 28 points in order?
Yeah, if we can, no, I mean, I'll just show you the HW. I mean, this is my data frame. So there are like totally 28 values. So when I execute the residuals, it gives me the difference between this and the model which we built. Yeah.
Can we get a residual plot? Is there a function for that?
Plot of residuals you want? Okay, yeah. I think by this it should give us. Yeah, this is how it looks between the residuals and the actual weight.
So weight was the y variable?
Yes. Yeah, you can see it in the model which I specified here. Weight is the y variable and height is the x variable. So based on height, I'm trying to get the weight value.